Welcome back, Algebra Kids. We're going to go ahead and work on 1,4b, and we're going to start looking at fractions and decimals. 1,4b, we're breaking up into fractions and decimals, and then I'll have a second video for talking about the distributive property. So the first thing we need to know when we're talking about working with equations that have fractions and decimal is the LCM, also known as the least common multiple. This is a really big thing that you need to know to be able to work with fractions and decimals. So it's the smallest number that can be divided by all the numbers involved. So a nice way to find LCM is go ahead and just list the multiples and find the smallest number they have in common. So if I have 5 and 2, I would look at multiples of 5. So 5, 10, 15, 20, 25, 30, 35, so on and so forth. And then I can look at multiples of 2. 2, 4, 6, 8, 10, 12, 14. And then I'd find the number that's common between them, but the smallest one. So 10 is the first one that appears in both of them, so our LCM would be 10. Now, some people need to write out their lists, and some people can look at them and figure it out. Now, the biggest mistake made is thinking that you can just times them and that's going to be it. In this case, it is. But if there's a common factor between the number, there's actually smaller values. So something like, let's see, 6 and 9. So if I was looking at 6 and 9, I could make my list, and I would actually, if I were just times these, 6 times 9 would give me 54. 54 is not my greatest or my lowest common multiple. In fact, the lowest common multiple is 18. 6 can go into 18 and 9 can go into 18. So don't fall into the pitfall of you could just times them. You can just times them and use them to do all the different methods that we're going to be using, but you're going to find yourself working with much bigger numbers, and it's going to cause more of a headache. So sometimes you have 2 fractions, and then you'll look at the LCM of these 2 numbers, but sometimes you have 3 numbers. So if I'm looking at 3, 4, and 12, what's the lowest common multiple? So again, you could do the list and it looks like 12 actually is the lowest common multiple for them both. But if you were to multiply 4 times 3 and then times by 12, you'd get the number of 144. And working with a number as big as 144 can be really frustrating. So I recommend either finding a way to do it in your head or making some lists. So very similar to that one, we have 4, 2, and 8. 8 would be your LCM, lowest common multiple, because 4 goes into 8, 2 goes into 8, and 8 goes into 8. And then 5 and 3, that would give us 15. So how are we going to use these? So over here we have an equation. We're going to follow our same processes that we've been using. We're going to draw a line to indicate our 2 sides. We're going to identify which side the variable's on. So here's my variable. And then we're going to get rid of all of our fractions. So to get rid of my fractions, I have to look at what's on the bottom of the fractions. So when I'm looking at this, I have a 5 and a 2 on the bottom. So I would look for LCM of 5 and 2, which we already did on the last page, and we found the LCM of 5 and 2 to be 10. So what I'm going to do is I'm going to multiply what we call every term by 10. And so every term is anything separated by a plus or minus. So I'd multiply this by 10, I'd multiply this by 10, and multiply this by 10. And then we can simplify. Now you have multiple ways to simplify this. I'm going to go ahead and do the standard. I times the top number by 10, not the bottom number. So 10 times 2 gives me 20. That bottom number stays 5. I multiply the top number by 10. 1 times 10 is 10. I keep the bottom number the same. I multiply it 5 times 10. Now I simplify the fraction that is there. If you did your job right, this will simplify into a nice integer. So 20 divided by 5 simplifies to be 4x. Minus 10 divided by 2 simplifies to be 5. And now we have our normals, two-step equations that we just talked about the other day. So from here, we go ahead and we get rid of everything on that same side. Remember that variable right here? We're going to get rid of that. So I get rid of my subtraction first. So I add 5 to both sides. So now I have 4x equals 55. I divide by 4. That cancels out. And now I'm left with 55 over 4. You can turn it into a decimal, or you could leave it right this. You do not have to turn it into a mixed number. In fact, I prefer you not turn it into a mixed number, because if I have to plug this into something else, it's easier to leave as an improper fraction. And this improper fraction cannot be reduced, so that would be my answer. Okay. So moving on to the next problem, and again, you're going to see repetition between our LCM problems and our problems here. So when I look at this first problem here, I have a denominator 3, 4, and 12. So I'm looking for the LCM of 3, 4, and 12, which earlier we determined was 12. So I times each term by 12. And now on this time, I'm going to go ahead and show you the shortcut. So last time we times the top and then divided. We're going to work opposite. I'm going to divide first. So I'm going to go ahead and take this 12 divided by 3, and that's going to give me 4. But I still have this 2 on the top, so then I'm going to do the times. So here, I'm going to divide first. 12 divided by 4 gives me 3. So I have a 3, and then I have a 3 left on top. Here, 12 divided by 12 gives me 1, and I times it by what's left on top, 7. And so that's another way of working with it. So that way you're dividing smaller numbers, and then you're just multiplying. Because some people find dividing harder than multiplying, so it's easier to divide the smaller stuff first and then times. But it is up to you which route you want to go. So for here, 4 times 2r would give me 8r. 3 times 3 gives me 9. 1 times 7 gives me 7. And then I'm just back to my normal two-step equation. Here's my r. And then from here, I'm getting rid of my plus or minus first. I have plus 9, so minus 9. I have 8r left. 7 minus 9 is negative 2. I divide by 8. And so here, you can divide and turn into a decimal, or you can reduce the fraction. This does reduce, so you must reduce it. So this can divide by 2. This can divide by 2, which gives me negative 1 on top and 4 on the bottom. If you turn it into a decimal, it'd be negative 0.25. Both are correct and completely valid answers. Okay, so for the next one, again, we're looking for that LCM of 4, 2, and 8. The LCM we determined earlier was 8, so I'm going to times everything by 8. I prefer to divide first because for me it's easier to divide smaller numbers in my head, and I rarely use a calculator or have a calculator wherever I'm working. So I'm going to go ahead and divide first. 8 divided by 4 gives me 2. And then I times by what's left, so I have a 3r on top. Plus, now I'm going to divide these two. 8 divided by 2 gives me 4. I times it by what's left on top. 8 divided by 8 is 1. I times it by what's left on top. So from here, I'm going to go ahead and multiply. 2 times 3 is 6r. 4 times 1 is 4. 1 times 7 is 7. So from here, again, I'm looking for that variable. I'm moving everything away from it. So I start with my plus minus. I have plus 4. So I minus 4. Now I have 6r equals 3. I divide both sides by 6. Since these are side by side, I divide, because that's a multiplication. So 6 divided by 6 gives me 1r, which is the same thing as r. 3 divided by 6, again, I can On my calculator, type in 3 divided by 6, or I can simplify my fractions. I can divide top and bottom by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. If you used a calculator and turned it into a decimal, it'd be 0.5. And those are your 2 possible answers. Okay, so just a couple more. Next one, LCM. So again, I'm looking at the numbers on bottom. I have 5, 3, and 3. I don't have to list 3 again because it's the same number, so the LCM of 5 and 3 is 15. So I multiply by 15. So now I'm going to go ahead and use the other method. I'm going to multiply first, then divide. So I times the tops. 15 times 1 gives me 15. That bottom does not change, it's over 5. Plus 1 times 15 is 15 over 3. And that's equal to 8 times 15. See, 8 times 10 is 80. 8 times 5 is 40. 80 plus 40 is 120. And that's over 3. So what I just did is kind of a distributive property. I multiplied by the 10, and then I multiplied by the 5. And then I added them together. Now I go ahead and divide. So 15 divided by 5 becomes 3. 15 divided by 3 becomes 5. And 120 divided by 3 becomes 40. So now I draw my line. I move my stuff. I start with my subtraction and addition. So I have plus 5 to undo it, I minus 5. So now I have 3r equals 35. 3r means 3 times r, so to undo times I divide. So r is 35 over 3. Again, you could turn it into a decimal. I prefer not to, just because that wouldn't be something I can easily do in my head, and I know that that won't reduce. So a lot of different options for you. Again, we're looking for technically correct. Are you showing your work? Is it all mathematically sound? Is your answer technically correct? If it can reduce, you reduce. You don't have to turn it into a mixed number. If you want to turn it into decimal, that's fine. It has to be an accurate decimal though. Okay, so for the next one we have 1 fraction. So what we're going to do is we're going to use that fraction as our multiplier. So here, my LCM between 6 and nothing else is really just 6. So I'm going to times by 6 here, times by 6 here, times by 6 here. So here I'm going to go ahead and do the division. So 6 divided by 6 becomes 1. So this is really a 1x, or x. Plus 4 times 6 is 24. And 15 times 6 would be 60, and 30, which is 90. Now 1x is really just x, so I'm going to go ahead and change that to x, because I don't want to have an extra step if I don't have to. So now all I really have to get rid of is that plus 24. So the opposite of plus is minus. So x is, let's see, 10, 8, 3, 6, 6. So 66. Okay. And the last step we're going to talk about is decimals. And then we'll move into the next video, which is distributive property. So with decimals, what we do is we look at how many decimal places there are. So my first problem here, I have 1 decimal place, 1 decimal place, 1 decimal place. So all of them have 1 decimal place. And if it has 1 decimal place, up here, 1 decimal place means I'm going to multiply by 10. So I multiply each thing by 10, and what it really does is it takes my decimal and it moves it 1 spot to the right. So this now, when if I times by 10, times by 10, times by 10, remember we're timesing every term by 10, it's moving that decimal to 1 to the right. So the decimal now, this becomes 12y. 1 to the right, so it becomes 57. 1 to the right, so it becomes 15. Then I just draw my line, and it's just like every other problem. So I get rid of the minus 57 by adding 57. Always moving everything away from that y. So now I have 12y equals 12, carry the 1, 72. And then that's 12 times y. So to undo times, I divide. Okay, I know that can reduce, but I don't know if it goes evenly. And it does. I pulled out my cell phone. 72 divided by 12 gives me 6. Okay, so on to the next problem, which is a little different because this one had, all of them had 1 decimal place. Well, the next one is a little weird, a little funky. This one has 2 decimal places. This one has 1 and this one has none. So I take the most number of decimal places, 2. And that's what I'm going to use to determine what I multiply by. So if I have 2 decimal places, I'm going to multiply by 100. That's also the same thing as moving my decimal to the right 2 spots. So 1, 2 gives me 2x. 1, 2 gives me 140. If I take this 1, 2, and for every spot that I'm moving, I'm adding in a 0. So from here, now I've got my 2-step equation. I'm going to go ahead and solve. So I always get rid of addition, subtraction first. I have plus 140, so I minus 140. So now I have 2x equals negative 240. Now that's 2 times x, so I divide by 2 on both sides. And x is negative 120. And that's it. So look for the next video on distributive property, and I'll see you later.